Welcome to part two of the pollutions lecture. So, we've reduced pollutant emissions a ton since the passage of the Clean Air Act in 1970. Um, and the really good news about that is that obviously, since 1970, the population has increased. We have more vehicles on the road. So, it's a really good sign that there have been great changes made in the last 50 years or so in order to help clean up a lot of air pollutants. One of the technologies that's really important when we're talking about smokestack emissions, so like let's say emissions from a coal burning power plant, is a scrubber. So scrubbers are attached to smokestacks, and they work in a couple different ways. Sometimes very simple scrubbers can just spray water down over the top of the emissions that are getting ready to come out of a smokestack. And the water will attach to all the little particulates, carry them to the bottom of the scrubber, and then they go into a tank basically where they settle out. Um, Other scrubbers are a little more advanced and they might use specific chemicals to target specific particulates that are coming out of the smokestack and kind of work in the same way. There are some scrubbers that are electrostatic, meaning they have panels in them that are charged. And those charged panels then will collect different particulates and then eventually be cleaned so that those particulates don't go out into the air. Now, scrubbers are great at removing those particulates and bad things out of the air, but that stuff's just not going away somewhere magically. All of those solids that settle out in the settling tank have to be disposed of somewhere. And a lot of times they're considered hazardous material because they're going to contain heavy metals and things. So they have to be disposed of in a special way. And that can mean a lot of expense and having to find a place where you would dispose them. Another advancement in terms of air pollution are catalytic converters in cars. And so, even though leaded gasoline has really been phased out in most places, there are other emission concerns when it comes to cars. So, um, carbon monoxide and nitrous oxides in your vehicle exhaust are a concern. So, most cars have catalytic converters, which will take those two things and convert them into carbon dioxide, water vapor, and nitrogen. There's a much more complex diagram on the next slide. You don't need to know all the chemical details, but what you do need to know is that there's metals inside the catalytic converter. They take the carbon monoxide, they take the nitrous oxides out of your vehicle exhaust and convert them into those three things: carbon dioxide, water vapor, nitrogen gas. And those are much less dangerous to be then emitted out of your muffler. Here's the complex diagram I was talking about. You don't need to know all of the little details here. Again, just know that very basic formula. So today, the EPA and individual states monitor 6 criteria pollutants. They're the 6 pollutants that are known to cause the most human health hazards. And there are standards, very specific standards that are set for each of these 6 pollutants. Now, 4 of those pollutants we've already talked in detail about. So I'm not going to give you new information about those. Those are carbon monoxide, sulfur dioxide, particulate matter, and lead. But there are 2 other criteria pollutants that are more specific and are monitored by the EPA and by states individually. One of them is nitrogen dioxide. It's part of that family of nitrous oxides that we talked about before, and it's highly reactive. It basically is formed from car exhaust. That's one of the main forms, and other types of combustion. And we worry about it because once it gets out into the atmosphere, it can mix with moisture in the atmosphere and make acid rain. It's also one of the key components of smog. So it's definitely something that the EPA monitors and individual states monitor. The sixth thing that is monitored is tropospheric ozone. And this is a big deal. And you've probably heard about this too. You maybe have seen, like on a weather app or maybe on the evening news, that there's an ozone alert. And that's because there are several monitoring stations all over the United States and in other parts of the world that are looking at air samples to monitor for tropospheric ozone. Remember, we like there to be ozone in the stratosphere. That's a good place for it to be because it helps block out UV radiation. But when you bring ozone into the troposphere, down here where we are, where we're breathing, it's a huge health concern. It causes a lot of respiratory distress, and it can even cause tissue damage to other tissues in your body. It even is damaging to structures in your home. It's damaging to plastics and things like that. So it's definitely a place that we don't want to have, or the troposphere is definitely a place that we don't want to have ozone. Um, how do we get ozone in the troposphere? Well, what happens are those nitrogen oxides that we talked about earlier, and other carbon containing chemicals that are in the atmosphere. When they are in the presence of sunlight, they can form tropospheric ozone. And so that's why we talked about how Mexico City has a lot of problems with ozone and with air pollution. And that's because they receive a lot of direct sunlight, and they're very in an area that's very susceptible to developing tropospheric ozone.